Dear students, welcome to the video lecture by Dr. Biju Vasudevan. This topic is for week 5 of regular stream, Bessel functions and legendary functions. These two are the topics that we are going to see for this video. And I would like to recall the concept of series solution that you might have studied in elements of differential equations. If there is a function f0 of x y double prime plus f1 of x y prime plus f2 of x y is equal to 0 is second order differential equation, isn't it? And for a point x is equal to a, if you find this coefficient f0 of a is non-zero, then we call this point x equal to a is an ordinary point. If f0 of a, when you substitute here x is equal to a in the coefficient of the second derivative of y, and you get 0, we call x equal to a as a singular point. And then further there are two cases, regular singular or irregular singular points. That's okay. Now I just want to recall you what is an ordinary point and singular point. Okay, we are going to see these two different kinds of differential equations called Bessel's differential equation and Legendre's differential equation. And for that we have a set of solution pattern to be identified. Okay, this is the introduction. The first equation is called Bessel's differential equation. The solution of this kind of differential equation is called a Bessel function. The second one is called Legendre's differential equation. Solution for this kind of equation. You see here the solution of this one must be a function of v, depending on the value of v. And here the solution is depending on the value of n. N. So n is the parameter here, v is the parameter. So that's what we are going to say, Legendre's equation of order n. And here first one is Bessel's equation of order v. So Bessel's function is the solution of the first differential equation. Legendre's function is the solution of the second differential equation. That's what we are going to do. And here the point comes in. This is the coefficient of that is f0 of x is x square for the first function. So x equal to 0 makes it 0. X equal to 0 is a singular point for this, but it is ordinary point for the Legendre's differential equation. So that's the point. X equal to 0, origin x equal to 0 is the singular point for Bessel's function, Bessel's differential equation, but it is an ordinary point for Legendre's differential equation. Okay. Now the solution pattern, we don't be scared. I don't need to memorize this part. We want to say that there are two parts, jv of x and j negative v of x. For Bessel's function of first kind, when first kind will be for any v greater than 0. Any v greater than 0. If we get v is greater than 0, series converges, and then we know that this is jv of x and j negative v of x, or Bessel's function of first kind of order v and negative v. Okay, so we will write this one, y is equal to c1 constant 1 times j v of x plus constant 2 j negative v of x. So from the differential equation here, you see, you need to identify only what is v, and then substitute in this equation, you will get a solution. This is the solution for equation type number 1. If you get a differential equation of this type, which is a Legendre's Bessel's differential equation, then the solution is of this type, this one. Alright, here we go. Next, if we actually The next part, general solution is again is repeating. V is not an integer, just greater than greater than 0. That's all. This solution is true when V is not an integer. Right. Next, we find Bessel's function of second kind. Okay, we just replace this j negative v of x by another one y v of x. If you write this way, the answer is this Bessel's function of second kind of order v. Right. So you can either use this one or this one. Let's go. We don't want to expand all these things. Now differential equation solvable in terms of Bessel function. So this is another form of Bessel's equation. Here there is a coefficient for x square, a square. Okay? Now in this kind of differential equation, the solution set is given here. There will be a multiplied with x, c1 jv of ax, c2 yv of ax. Otherwise you can say c2 j negative v of ax. Both are good. Okay, for second time. So is the type, depending upon the type of the differential equation, we should choose the correct solution for this one. That is it. Now another form of differential, Bessel's differential equation, y double prime, the coefficient. See, in the previous case you have coefficient x square. In the equation number 1 also you have the coefficient x square. Okay, but here y double dash alone, the coefficient of y prime is this one, and the coefficient of y is this one. Okay, and equal to 0. Here p greater than 0, you have to find b, c, a, b, c and p. There are 4 constants to be found, a, b, c and p. If you know all these 4 terms from this differential equation, you can write this the solution. Y is equal to x power a c1 jp, not v. See here there is no v here. Jp of b x to the power c plus this x power a is common, c2 of yp of b x power c. This is the equation number 19. So if you identify a, b, c from these kind of differential equations, we have an example coming up, right? Then you write the solution in this form. This is what we are going to do. Next, properties of Bessel's functions. What is given? Properties of Bessel functions. J negative n of x is negative 1 to the power negative m of x, negative 1 to the power m jm of x, right? So you know j minus 1 of x, you can write minus jm of x. You can write minus 2 of x here to 1 minus 2 of x will be j2 of x. This is b1 of x is possible. So how to rearrange the term? This is another property, and here jm of minus x is equal to, what is it? Let's take j2 of minus x is equal to minus 1 to the power 2 j2 of x. So it will be positive. So when m is even, the function is even. The Bessel function is even. That's what is given here. Property 2 indicates that the jm of x is even if m is even. It is odd function when m is odd function, because we know f of negative x is equal to f of x, then f of x is even function. If f of negative x is equal to negative f of x, it is odd function. So this property will work here. If m is odd, you will get odd function. If m is even, you will get even function. Another property, jm of 0 is 0 for m greater than 0. If m is equal to 0, then jm of 0 is 1. And the limit of ym of x is, when x goes to positive 0, is negative infinity. These are some properties of the Bessel's functions, right? Next, Legendre function. We are not deriving Legendre function. We know the differential equation of this form, and we are finding series solution here. We don't want series solution. Its general solution has been given here in the last page. There are 2 kinds of solution. y1 and y2, isn't it? Note that if n is an even integer, the first this series will give you answer, and when n is an odd integer, this one will give you the second y2 terminus. So this will give you, for n is odd, you will get solution from here. When n is even, you will get solution from here. Okay, that's what given here. P is the specific nth degree polynomial solutions for Legendre's equation. The solution of differential Legendre's differential equation will be given here. What is it? For n equal to 0, 2, 4 even values of n, you will find solution. This even value, for even integers, you will find solution from y1. Okay, so when you simplify, when you put n equal to 0, 2, 4 in the equation number 1, you will find these solutions. And for odd values of n equal to 1, 3, 5, you can find this one from the second series, right? So there are 5 Legendre polynomials, actually solutions of the solution of the Legendre differential equation, and we know general form of the differential equation is given here, which is 1 minus x square y double prime minus 2xy prime plus n into n plus 1 y is equal to 0. This is Legendre's differential equation. When n equal to 0, this part will not be. So for this will be the differential equation when n equal to 0. So this will be the P0 will be the solution of this one. P1 will be the solution of this one. P2 will be the solution of this equation, n equal to 2, isn't it? P3 will be the solution of this equation, and so on you can find. So they are different forms of n equal to 2, n equal to 0, you get this one. N equal to 1, you get 1 into 2 here. N equal to 3, 3 into n equal to 2, 2 into 3, 6. N equal to 3, 3 into 4, 12. So this coefficient is decided by the value of n. So obviously the solutions are given here. That's it. And some properties of Legendre's functions. Pn of negative x is negative to the power n of Pn of x. Obviously depending upon the value of n, isn't it? Depending upon the value of n. If n is an even or odd function, depending upon the choice of n, because it will retain the negative when n is even, it will eject the negative if n is odd. So obviously this property will tell you whether the function is odd or even depending upon the choice of n. And another important property, when you substitute n equal x equal to 1 in any of the previous terms, check this rules. X is equal to 1, what is happening? X equal to 1, 3 minus 1, 2 divided by second one. 3 minus 1, 2 by 2 is 1. So when x equal to 1, things will be 2. P of 0, P whatever the n, Pn of 0, wherever you substitute x equal to 1, it will be 2. It will be 1. X equal to 0. Check the property one more time. X equal to 1, the answer is 1. So wherever in all this 6, or if you find P6, P7, 8, wherever you find x equal to 1, the answer will be 1. Here, check for every property, you can check. And Pn of negative 1, if you substitute x equal to negative 1 in all the equations, it will change negative and positive depending upon the choice of n. If n is odd number, it will be negative. If n is even number, it will be positive. Check with this one. N is odd number, here P1 of negative 1 is negative 1. P2 of negative 1 is positive 1, isn't it? So for even number, you get positive 1. So Pn of negative 1 is negative 1 to the power n. Second property. Or third property. Fourth property, Pn of 0 is 0. For n is odd. For all n is equal to odd, go to the first 3 numbers. Put x equal to what? X equal to 0. The answer should be 0. When x equal to 0, no, n is odd, isn't it? When n is odd, so take these three, put x equal to 0. X equal to 0, this will be 0, 0, 0, isn't it? When x equal to 0, the odd Pn will be 0. Pn of x will be 0. And but the derivation of this will be 0 when x equal to 0. That is what second. Next value. The derivation of Pn of when x equal to 0 is 0. When n is even. For n equal to odd, directly the function is 0 when x equal to 0. When n is even, so derivative is 0 when x equal to 0. That is it. So these properties may be useful for us. Now, okay. Now the question is, compare the equation number 1. What is equation number 1? I write it here. x square y plus xy prime plus x square minus v square of v is equal to 0, isn't it? This is equation number 1. The solution you should know. What is the solution? And the solution of this one. Y is equal to C1 gv of x plus C2 j negative v of x. You can write negative v or yv of x. You can write. Okay. Okay, compare this one, but we don't want a coefficient for x square, isn't it? In this equation, for problem number 3, divide by 4, what do you get? We want only v square. This will be x square y double prime plus xy prime plus x square minus 25 over 4 y is equal to 0. What is v square? V square is 25 over 4, gives v a positive 5 over 2. Isn't it? Therefore, what is the general solution? Y is equal to C1 j 5 over 2 of x plus C2 j negative 5 over 2 of x. Instead of negative 5 over 2, you can write second function, case function. So the second order function. That's it. Function of second kind. Yv of x can be written. That's it. That's the solution for the problem number 3. Just try this same for problem number 5. Problem number 5. I don't want to erase everything, just to find. We have the same x square. We need to multiply by x. Multiply by x. What do you get? X square y double dash plus x y dash plus x square y is 0. So x square y, v square is 0. V square is 0. V is also 0. So the solution y is c1 into j0 of x plus c2 into j0 of x. Further, if you want to find the value of j0, you can go back to this equation. You find j here, jv of x, substitute the value of v in the summation and expand it. It is possible to find, but that's not our purpose here. We are not finding it. Okay. Okay, that's it. Next question. Use equation number 12. What is equation number 12? I would like to show you the equation number 12 here. It's a general solution. What is equation number 12? X square y double prime plus xy prime plus there will be coefficient a square x square minus v square y is equal to 0. So there is an a square multiplied with x square, for which general solution y is equal to c1 jv of a times x plus c2 j negative v of, or we can write yv of ax. So we need to find only v and a. Okay, compare this equation with this is equation number 12. Compare with the equation, compare 7 with this one. A square is 9, a is equal to 3. V square is 4, v is equal to 2, isn't it? Okay, write the general solution for first case. Y is equal to C1 J2 of 3x plus C2 Y 2 of 3x. You can write J negative 2 of 3. This good. Both are good, right? Okay, do the same for 9. Problem number 9. A square is 25, gives A is equal to 5. B square is equal to 4 over 9. B positive is equal to 2 over 3. Therefore, general solution Y is equal to C1J 2 over 3 of 5x plus J negative 2 over 3 of 5x. That is it. That is it here. The next problem is coming up. The solutions are given here. Next problem is use indicated change of variable to find the general solution of the given differential equation on the interval 0 to infinity. Okay, we have to substitute y is equal to x power, what is it? Y is equal to x to the power negative half and u of x. Convert this differential equation into any of the known forms of Bessel's differential equation and write a general solution, isn't it? So we have to convert. Instead of y, answer will be in use, so we will be back to y again. So substitute. We want to substitute y here, we want y prime, we want y double prime. So to substitute here, this is y double prime, this is y prime, this is y. So we want to substitute y prime and y double prime. From this equation, find y prime. Find y prime. I will solve this problem on a separate sheet. Remember this term. And okay, we will solve a separate sheet. Okay, whiteboard. The given differential equations x square y double prime plus 2xy prime plus a square x square y is 0, and we are asked to choose a new variable y is equal to x power negative half u of x. Now we want to find f y double prime and to substitute in this equation. So y prime is equal to, differentiate this one by product rule. Keep x power negative half, differentiate u prime, plus keep u of x, differentiate this x power negative half, you will get negative half x power negative 3 over 2. Okay, we can further find second derivation as it is y double prime. We can find y double prime. Okay, and use product rule again here. You can keep the x power negative half as it is and differentiate u double prime of x. Keep u prime of x, differentiate x power negative half, this negative half x power minus 3 power 2. Next go to this function again, uv method. Keep, so differentiate u prime of x, keep the second term negative half x to the power minus 3 power 2, plus keep this u of x and differentiate this constant is negative half, it will be again negative 3 over 2 x power 5 negative 5 over 2. So this will be negative 3 over 4. So we want to expand this, can be this constant can be written as 3 over 4. That's it. So we got y double dash, y dash, y double dash. Now we substitute them in equation number 1. Okay, we substitute them. So what do you get is, so we have to substitute here y double dash, here 2x times y dash and a square x square times y. The next page will do it. So x square times y double prime plus 2x times y prime plus a square x square y is equal to what we are writing, x square times y double prime. Write down the y double prime. U double prime of x power 3 by 2. There are 4 terms, so you check here what this one, x u double dash x power negative half u dash. When you take u dash common, there are 2 terms. What is it? Negative half and negative half, x power minus 2. So can we make it common? X power okay, we will make it common. We will multiply this letter x square inside. First we will write this one, x square u double dash x power minus u double dash x power minus 1 by 2 plus u dash of x minus 1 by 2 x power minus 3 by 2 plus again u prime of x minus 1 by 2 x power minus 3 by 2. Fourth term for this one is u of x 3 by 4 x power minus 5 by 2. And now 2x times y prime. Y prime is x power negative half u prime of x plus u of x negative half x power minus 3 over 2. Finally, a square x square times y. Y is x power negative half and y is given, y is what, x power negative half and u of x. It should be 0. That's what they say, equation should be 0. Now multiply x square inside of these 4 terms, simplify it and check it. What do you get? U double prime 2 4 minus, this is actually minus 1, isn't it? X power 3 by 2 first term. Second term u dash of x. Okay, we will simplify later on. Second term, there is a negative here, so it will be negative u dash of x half and half, it will be 1. Negative of negative of, it will be 1, isn't it? You can make it u dash of x. Okay, 2 times half, it will be 1, negative 1 u dash of x power minus 3 by 2 into x square. What is it? X power x square into x power minus 3 by 2. What do you get? 4 minus 3 by 2 x power, this is minus 3, 4 minus 4, 3 is 1 by 2, x power 1 by 2, x power 1 by 2 plus The last term is u of x into 3 over 4 u of x into x power minus 5 by 2 into x square 4 minus 5 minus 1 by 2 x power minus 1 by 2. This x square is multiplied here with this x power this is x power negative 1 by 2 x power 3 by minus 3 by 2 x power minus 5 by 2. Then things are changing like this. And this is the first three terms for this one. Next next two terms for 2xy prime, we take it from here, multiply 2xy prime, we get is 2x half to the power half u prime of x, and you multiply this 2x here, isn't it, and minus half into 2, isn't it, 2 into half will be cancelled, so minus 1 x times u of x and x power minus 3 by 2, because x is multiplied, x is here 2x. I can simplify this x to this one. I can write this one as minus 1 by 2, x power minus 1 by 2. So 2x power half here into u prime of x minus x power minus u of x, x power negative half. And finally this term, what is it? A square, x square into x power minus 2 will be x power 3 by 2 u of x. Is it somewhat clear? No. The next page we will simplify further. We will simplify the equation. This one, u double dash x power 3 by 2, u double dash x power u double dash x power 3 by 2. What is the next term? Negative u dash x power half, negative u dash u of x, you assume that u of x power half, 3u over 4 x power negative half, 3u over 4 x power negative half. Next 2 into x power half u prime, 2 into x power half u prime, isn't it? We are going to collect u double prime, u prime, and use negative u x power negative half, negative u x power negative half. Finally a square x power 3 by 2u plus a square x power 3 by 2u. U is u of x. Wherever u comes, you can write u of x. Okay, that's not an issue, which is equal to 0. Now we are rearranging it. What we get? This one is x power 3 by 2 u double prime. Now u prime should come under one roof, all the u prime, isn't it? Plus u prime, I'm taking here, this term has u prime and this term has u prime, that's all. Other terms have only u. What do you get? 2 x power half minus 1 time x power half. The answer will be x power half plus u. When you take u outside, 3 by 4 you take u outside. What are the other things in the bracket? Here there is a u, here there is a u, here there is a u. So 3, negative 3, so x power negative 3 over 4 plus 1, so minus 1 by minus 1 by 4 and minus 1 by 4 times x power half, because this is positive 3 by 4 and negative 1 here, negative 1 here, positive 3 by 4, and x power 1 by 4 to common, and this term, last term is a square x power 3 by 2. This is what you get when you simplify. Now we are multiplying this equation by x power negative half. So what you get when you multiply every term? X power negative half into x power 3 by 2 will be negative half, it will be x square. X square u double dash 3 by 2 minus 1 by 2. Okay. We multiply here. 3 minus 2 by 2, it should be 1. It should have been positive 1 by 4. So it will be, when you multiply by x power 1 by 2, you will get, yes, it will be, okay, it will be positive 1 by 2, x power 1 by 2. Yes, multiply by x power 1 by 2. First time will be 3 by 2 plus 1 by 2 will be 4 by 2, 2. Second time will be x into u prime. Third term will be a square x square minus 1 by 4 u is equal to 0. Now this is a Bessel's equation, Bessel's differential equation in the variable u, where a square is a square, a square is a square, v square is 1 by 4, v is 1 by 2. V is 1 by 2. So the general solution, we know the general solution of this Bessel's equation. What is the general solution? General solution is u of x is c1 j 1 by 2 of ax plus c2 j negative 1 by 2 of ax. But we are looking for y. What is y? Y is x power negative half into u of x. So y is equal to, the final general solution for y is x power negative half upon this one, c1 j half of ax plus c2 j negative half of ax. That's the end of this problem. That's the end of this problem. Now let us see what is next. This problem has been solved and then answer is given here. Use 18 to find general solution. Now we have to compare with a different form of Bessel's differential equation. That is here, equation number 18 I will show here. Y double prime plus 1 minus 2a over x times 2a over x times y prime, plus there is a constant which is b square c square x power 2c minus 2 minus plus, here it is plus a square minus p square c square divided by x square times y is equal to 0. This is the equation number 18 in this PowerPoint, you can check. Now if you find ABC from this problem, if you find A, B, C and P, your general solution y is equal to x power a c1 jp of b x power c and c2 jp of b x power this is j negative p or yp, you can write, isn't it? That is the general solution. We are looking for this one, isn't it? But this is 19, equation number 19, textbook. Okay, from the first one, Compare this one. There is a coefficient x, the x for divide by, for problem number 15, divide by x first. Divide by x, what you get? Y double prime minus 1 over x times y prime plus y is equal to 0. Now compare with 18. You have 1 minus 2a whole divided by x, just 1. So 1, how to compare this one? 1 minus 2a is equal to 1. So what is a? Find. Do you have negative value here? So that is negative value. Negative 1. 1 minus 2a is equal to negative 1. That is 2a is equal to 2. A is equal to 1. This negative 1 over x should be equal to 1 minus 2a over x. So negative 1 is 1 minus 2a. Equate them, you will get 2a is equal to 2a is equal to 1. We found a. Go to the second term here, and I mean third term, the coefficient of y. Y is coefficient, but there is no division x square, isn't it? So this part will be 0. A square, this part a square minus b square minus c square will be 0. So a square minus b square times c square is 0. Will be a square is p square c square is possible when p and c are 1, because we know already a is 1. So a, p, c are 1. When a, p, c are 1, the second term will give you 2c minus 2. 2x power 0 will be 1, and b and c, everything should be 1. b should also be 1. So just comparing the terms, we will find a, b, c and a p. Therefore general solution y is equal to x power 1 c1 j1 of b is 1, so x power 1, c is also 1, plus c2 y1 of x. That is the end of this problem. Try second one yourself. You want me to solve the second as well? Okay, we'll do it. We'll do it. Problem number. Again, we have to write all these equations. So just take eraser and erase unnecessary part. Eraser. Now we want okay. Problem number 17. Problem number 17. We don't want a coefficient for y double dash. So divide by x square. What do you get? Y double prime plus 1 minus 2 over x square times y is equal to 0. There is no y prime. And we have to compare everything with the coefficient of y. See, this term power above x square, there is a square minus b square and c square, which is here equal to 2, which is here equal to 2, and the left side, and of course the y prime is 0. Why y prime is coefficient is 0? Because the coefficient of y prime should be 0, isn't it? So 1 minus 2a should be 0, otherwise y prime will not be 0. So the coefficient of y prime is a variable x, ignore it. The power, the numerator is 1 minus 2a should be 0. So 1 is equal to 2a, a is equal to 1 by 2. We found a is equal to 1 by 2. Use it here in this equation. This is 1 by 4. Another information, b square x power this there is no x in the coefficient of y, there is no x here, so it should be x power 0. So x power 0, x power 2c2 is equal to x power 0 is 1, isn't it? So it should be 1. Therefore x power 0, 2c minus 2 is 0. 2c is equal to 2c is equal to 1. We found a, c, anything else we will find p. If you know c, we will find p using this one. Find what is b. B also should be 1, because b square and c square x power all is equal to this 1. Therefore b is also 1. A is half, b is 1, c is 1. Substitute here. A square is 1 by 4, p square is to be found, c square is 1, is equal to 2. So 1 by 4 minus 2 p squared minus this p minus p square is minus p square is 2 minus 1 by 4, which is p square. You can find p 8 minus 1, 9 over 3. 9 over 3 is 1 minus p is 1 by 4. 9 minus 9 over 4. 9 over 4. This is 84. Therefore, we get negative p square is equal to 9 over 4. You cannot take square if there is a negative. Check the values with this one. If a is positive 3 by 4, it satisfies this equation or not. Check. A is 1 by 4, 1 by 4, 1 by 2, 1 by 2 square is 1 by 4 minus, take the square root as 3 by 2, check it for positive value. This is 3 by 2, 9 by 4 is equal to 2, so it will be negative 2. It should have been negative 2. It should have been negative 2, right? Of course. Then it will be negative 9 by 4. P square is equal to, yeah, that's right. It should have been negative 2. And then we solve this one. P is 3 over 2. Once you find A, B, C, D, A, B, C, A is 1 by 2, C is 1, B is 1, P is 3 by 2, substitute in this equation. That will be the end. Okay, thank you. We will do it another problem. Solution is given. Another problem is again kind of Legendre function, isn't it? Use the change of variable. S is equal to this term we are going to use. What is this? Can you exactly write? S is equal to 2 over alpha square root of k over m e raised to minus alpha t over 2 exponential, isn't it? This is what happening here. This is what is given, e power minus alpha t to t over 2. We had to replace this variable to show that the differential equation, this equation can be converted into this form. So we are going to find x double dash and substitute in this equation. X double dash, what is it? D square x by dt square, right? We have to find it and substitute here. Okay. Let's take a page, a different page, and then we'll solve it on this. Fine. What is it? What is the given equation? mx double prime plus k into e power minus alpha t times x is equal. This is second order differential equation in x. X double prime stands for d square x divided by dt square, right? So first we are going to find dx over dt. Assume that we have taken a variable s is equal to 2 over alpha square root of k over m. Only this term is under square root. E raised to minus alpha t over 2. This is the given change of variable, isn't it? When you differentiate x over t, assume that x is a function of s, x is a function of s, and if s is a function of t. Using chain rule, we will differentiate dx over ds and then ds over dt. X is a function of s and s is a function of t, right? Okay. Differentiate s with respect to t here, ds over dt. All the terms are constant except the exponential. So it will be 2 over alpha square root of k over m e raised to minus alpha t over 2 into 1 by 2 into alpha by 2. Negative alpha by 2 is the constant. So when you 2 can be cancelled here, this 2 can be cancelled, this 2 alpha can be cancelled. So negative, when you differentiate ds, you get negative square root of k over m e raised to minus alpha t over 2. So we will write dx by dt as dx over ds into negative square root of k over m into e raised to minus alpha t over 2. Now second derivation d square x by dt square. Let's do in the next page. This page is crowded, isn't it? Again, d square by dx, d square, how to write d square x by dt square. Differentiate this entire result by again with respect to t. So d square by dt square is equal to d by dt of the previous result. Previous result is dx by ds multiplied by negative square root of k over m e power minus alpha t over 2. Isn't it? This one and this one. So this is u product rule. Again, inside the different, this is u, this is v, you have to use product rule. So first we can keep the dx by ds as it is, this one. Differentiate the second term with respect to t. Again, what do you get? Minus square root of k over m e raised to minus alpha t over 2. Minus alpha t over 2, minus alpha over 2 is constant. This first part, plus keep this part as it is, keep this part as it is. What is this? Minus square root of k over m e power minus alpha t over 2. Differentiate this dx by s. What do you get? d square x divided by ds square and then ds over dt. This should be the way. Differentiate x with respect to s and then s with respect to t. And this ds by dt already known. We are going to use it here. ds by dt. So finally I am going to expand every time. A little bit. Okay. What is this? Dx square by dt square. Here dx over ds. Simplify this term. What is it? Minus and minus will be alpha over 2 square root of k over m e raised to minus alpha t over 2. That is in this term, right? Next term minus it's going on. Simplify second term, we will expand actually. Plus here this term minus square root of k over m e raised to minus alpha t over 2 d square, right, d square x by ds square. Write this term from the previous table, ds by dt. Go back, it's given here, ds by dt 2 over alpha, that is given here, eh? Negative k over square root of k over e raised to minus alpha t over 2. That is it. Go there. So negative square root of k over m e raised to minus alpha t over 2. So the second term, there is a negative root k will be positive root k on e ds square x by ds square e power same term twice, isn't it? This term and this term is repeating. Okay. What we got to simplify now? Multiply these two terms repeating and then simplify. I'm going to simplify d square x over dt square, and we should remember our first equation, right? D square x over dt square. Go back. What is it? First term, this one, there is no change here, isn't it? Is equal to dx over ds alpha over 2 square root of k over m e raised to minus alpha t over 2 plus second term. When you multiply this, negative and negative will be positive. Root of k by m into root of k by m will be k by m. This will be e power alpha t by 2, e power alpha t by 2. To multiply this one, e power alpha t by 2 square, it will be e power alpha t. What you get finally is k over m e raised to negative alpha t d square x over ds square. This second derivative, and we got it. The equation given for us is, equation 1 is m into d square x by dt square plus k times e raised to negative atx is equal to what? Have to simplify. Just to multiply this equation with m. So substitute this one here. M times this is equal to 0 actually given. M times m is multiplied here. M times dx by ds into alpha over 2 square root of k over m e raised to minus alpha t over 2 plus m will be cancelled here when you multiply m. K into e raised to minus at d square x by ds square, this is only for the first time, plus k km km. So when you no, there is no m in the second term, this k e raised to minus at x is equal to 0. This is equation number, this is equation number 1, this is equation number 2. We are almost at the end. Now we have to multiply by some more term to get some s. Our s, you should remember what is the given s. Given s is 2 over alpha square root of k over m into e power minus alpha t over 2. This was given. So we have to get s here. What is missing here? 2 over alpha. You should not 2 should multiply by 2. So 2 square we should multiply here. Then 2 will be in the numerator. Alpha square in the denominator. So multiply by multiply by 2 square over alpha square times m in this equation. So here m and m will be cancelled. 2 square, we will expand this term in the next page. We get first term 2 square by alpha square m into k. Go back. Square root of into this constant term we will write first, right? K into e power x into e power minus. Okay. Otherwise, we check the first term. What is this one? In the decreasing differential order, so second order derivative we will write first. K into e power minus at multiply by this term. K into 2 square divided by alpha square m. Okay, that is what I mean. K into 2 square divided by alpha square m e power minus at and d square x over ds square. I didn't notice it, no problem. Second term, for first derivative, it will be 2 over alpha square root of k over m, check it, e raised to minus alpha t over 2 and dx over ds. Third term is 2 square over alpha square m k e raised to minus at x equal to 0. If you multiply this term everywhere, you will find this equation, right? Finally, we know s is equal to 2 over alpha e raised to minus 2 over alpha e raised to minus alpha t over 2 and square root of square root of k by m, isn't it? So what is s square? S square will be 2 square over alpha square e raised to minus at k by m. So wherever this term comes, we are going to replace here. See, 2 square alpha square divided by m k by m, isn't it? E power minus at. So the first term is s square d square x by ds square. Second term is 2 over alpha square root of k. This will be s times dx over s. Finally, third term is k over m 2 square over alpha square e power minus k. This one, isn't it? Plus a square x is 0. So we have got the required differential equation. Okay, differential equation, right? That's the end of this problem. Now let's go to this problem. This has been proved. This has been proved. Now Legendre's differential equation. There are two equations. We are asked to find this one. We have to show that this differential equation can be transformed into Legendre's equation. Legendre's equation, and you know the Legendre's equation 1 minus. So we have to convert this one to in this form 1 minus x square into y double prime minus 2xy prime plus n into n plus 1 times y equal to 0 by choosing x is equal to cosine theta. Shall we go ahead? The same sheet will go. Okay. We are given a differential equation. First we should write the given differential equation. What is the given differential equation? Sin theta d square y by d theta square plus cosine theta dy by d theta third term n into n plus 1 sin theta y is 0. Our choice given as x is equal to cosine theta. So what is dx over d theta, which is negative sine theta, isn't it? Now we want to convert into Legendre's differential equation, which will be d square y by d theta. We want to replace this term, isn't it? We have to find what is d square y by d theta square, what is dy by d theta. Okay. Let's take y is a function of what is it here? Y is a function of x and x is a function of theta. That's what you do. What is dy by d theta? Y is a function of x, so differentiate y with respect to x and differentiate x with respect to theta, which is already done here, isn't it? So dy over dx into negative sine theta. This is first derivative. Now second derivative, d square y over d theta square. Differentiate this one by product rule. Minus sine theta has been kept. Differentiate dy by dx. It will be d square y by dx square and then dx by d theta. Next, plus keep dy by dx. Differentiate sine theta. D minus is there, minus cosine theta. Again dx by theta should be used here, which is negative sine theta. Again negative sine theta will be sine square theta. So what you get in the next page is d square y by d theta square is sine square theta d square y by dx square minus cosine theta dy by dx. Okay, we will use all this in the equation number 1. This is our equation number 1, isn't it? Sine theta d square y by d theta square. So sine theta, multiply sine theta here. Sine theta, the d square y by d theta square, what take it? Sine square theta d square y by dx square minus cosine theta dy by dx. First term is done. Second term, cosine theta dy by d theta. Dy by d theta is given here, right? Cosine theta into this one. So plus cosine theta into minus sine theta dy by dx. Plus the last term is n into n plus 1 sine theta y. N into n plus 1 into sine theta times y is 0. Divided by sine theta. Everywhere there is a sine theta. Here a sine theta, here a sine theta. What you get is sine square theta d square y by dx square, which is y double prime, you can write this time, minus cosine theta. Cosine theta is given as x in the problem, x into y prime. This one is, okay, this is negative again, x y prime plus n into n plus 1 y is 0, and we know sine square is 1 minus cosine square, 1 minus cosine square theta into y double prime minus 2xy prime plus n into n plus 1 y is almost Legendre form. But replace x cosine as x, it will be, x is equal to cosine theta taken in this problem, 1 minus x square y double prime minus 2xy prime plus n into n plus 1 to y equal to 0. We have derived this equation to Legendre's differential equation. We have not been asked the solution, so stop it here. Okay, let's say, and the next problem is find the solution of this one. It's quite easy. what we have to do is general solution as for the general function yn is Pn of x, right? And y of 0 is 0 given by properties. You know that y of 0 is 0 means only Pn of 0 is 0 for when n is odd. N is odd, you know, Pn of, so y0 0 gives Pn of 0 0 for n. This is 0 only for n is odd. Therefore n, choice of n should be 1 and 3 and 5. Go to the properties, you will come to know properties of the generous function. You will understand this one. When n is equal to 1, what is lambda? Lambda is the coefficient. It's replacing the coefficient n into, so lambda is replacing the term n into n plus 1. When n is 1, gives lambda is 1 into 2. N is 3 gives lambda is 3 into 4, 12. N is 5, here lambda is 5 into 6, 30. Lambda is equal to 30, 12 and 2. So you can write the first three solution, lambda n equal to 1, 3, 5. You will find eigenfunctions from the properties we have seen. P1, P3 of x and P5 of x are the solutions of this legendary. We can find them from the introductory page. This is x, this is 1 by 2, 5 x cube minus 3x. This is 1 by 5. Check back here. I will show you the given solutions of Legendre's equation. This one. When n is 1, this is the solution. When n is 3, this is the solution. When n is 5, this is the solution, right? For n is equal to 1, this is the differential equation. N is equal to 3, this is the differential equation. For n is equal to 5, you find a differential equal to 60y. The solutions are given here. So, and we have a property here. You can see a property here comes up. Pn of 0 is 0 for n is equal to odd. So yn 0 gives this statement. Right? We have used only these properties to finish this problem. Oh, that's the end. Thank you very much. Let's enter this chapter. The answer is on the next page. You can find. Thank you. Stop recording.